So, children, our contemporary Einstein is present in front of you.
Hey, advanced students and any ET students, I would like to congratulate you all for making it this far. And also, I hope that you all will do very well in your future endeavors. So, thank you, everybody. And I guess we will get to the questions and answers now. Thank you.
So far as mathematics and physics is concerned, he is an iconic personality. So you are most welcome to ask some thought-provoking questions and give him a challenge.
If a twice differentiable function is symmetric about a line, say x equals a, then can we say that its second and third derivative would also be symmetric about that same line?
Oh, okay. So a twice differentiable function.
Twice differentiable.
Oh, three times. Okay, I see. So this is a whiteboard. So you said we have a twice differentiable function, a three times differentiable function that is symmetric around a line x equals a. So that means that f of, all right, so that means that f of x a plus x is equal to f of a minus x. And now we are asking whether the second and third derivatives will also be symmetric about this line. So, okay, actually this is not an accurate drawing since it should be symmetric, of course. Now, if it's three times differentiable, that can only mean it has to be differentiable at every point. So that can only mean that the slope is 0 at the junction point, or x equals a. So I'm just going to call it the junction point for easier reference. So the slope has to be 0 at x equals a. Now, a good example of this that I'm going to look to is probably sine of x. So it's infinitely differentiable. But as you have stated, this function is only three times differentiable, but let's assume that it's infinitely differentiable. So over here, we have that it's symmetric around x equals a, but then the derivative, which is cosine of x, is that also symmetric around the same exact line? Well, drawing it, oh wait, this is cosine. So the derivative should be negative sine. So the derivative is going to look like this. So let me just fix that very quickly. Okay. So we're asking if the second and third derivatives are symmetric. So first of all, it's going to look like this. So sine is going to be over here and then over here. Let me see. Does this correspond correctly? Okay, so over here and then over here. And then we want it to go back around. And it seems that it may be symmetric. No, it's not symmetric, actually. So that's the first derivative, but of course we want to take the second and third derivatives. So this is just an example to see what we can do in general. So then the second derivative is just going to be minus cosine of x, which is obviously also symmetric around that point. But the third derivative is non-symmetric once again. So really the question here is just going to be, is the second derivative differentiable? So here's what my thinking would be to that. So if we get no specifications other than this, we can't say that much, but let me think about what we might be able to say. Oh, right. I think I understand why this works. The second derivative is always going to be symmetric, and this is why. Via the chain rule, if we just take the derivative of this, we get this. Oh, which obviously doesn't satisfy the rules for being symmetric because this is negative. But then, if we take the second derivative, both sides go back to being positive. So that means f double prime of x does follow the criteria. And if it was 4 times differentiable, then any even derivative would follow the criteria. So it's a bit of a deep question. It takes a little bit of thought to figure out, but it should hold that any 3 times differentiable function, its second derivative should be symmetric around x equals a if it itself is symmetric across a. Thank you.